in addition to carboxylic acids, alcohols form esters with a variety of inorganic acids. These acids are typically sulfuric acid as well as derivatives, phosphoric acid, or nitric acid. We have actually already seen some of the derivatives of sulfuric acid reacting with alcohols to form sulfonate esters. An example will be this tosyl chloride, which is formally derived from sulfuric acid in a way, which in the presence of pyridine will react with an alcohol and give us this tosyl chloride, alkyl tosylate, as well as HCl, which is then trapped with a base. Very analogously, alcohols will react with sulfuric acid. This is an example reaction with methanol with sulfuric acid, which upon heating will replace one of the OH groups in the sulfuric acid with a methoxy group, and will lead to release of water. And then after exposing this to another molecule of methanol, we will get the so-called dimethyl sulfate. And this is an excellent methylating agent, and the reason why that is so is that, not surprisingly, in SN2 reaction, it will form a very good leaving group. So if we have dimethyl sulfate, attack here will eliminate the sulfonate to give us CH3CN, and this leaving group, which is because of its resonance stabilization a very good one. This is also a reason why dimethyl sulfate and similar methylating agents are very carcinogenic, because they're very good they're very good methylating agents, which means that even weak nucleophiles will attack them. And our body, especially DNA, is full of weak nucleophiles. Many of nitrogen-based nucleobases are weakly nucleophilic, and those nucleobases can be methylated then, which then leads to problems in the replication of DNA and sort of either mutagenic or carcinogenic effects. Alcohols also form esters with nitric acid, the so-called alkyl nitrates, and so this will be an example of one of those. React just an alcohol with nitric acid, we will get water as well as this alkyl nitrate ester. And alkyl nitrate esters are useful in the production of explosives, because compounds like nitrocellulose or nitroglycerin, the structure which is shown here, all have a lot of nitro groups, and that gives them, that means that upon their explosion, a large amounts of nitrogen gas is released, which then contributes to shock wave. So this will be nitroglycerin, which is a very good explosive. This would be an example of a similar, also nitrated explosive, although this is not formally an alcohol derivative, but this was nothing other than trinitrotoluene, TNT. Nitroglycerin, for example, has been used quite frequently in 18th and 19th century, but the problem with nitroglycerin is it's very shock sensitive, so there would be these terrible accidents during this production. And Alfred Nobel actually, I believe, lost a brother to one of those accidents, and so he discovered the fact that when mixed with diatomeous earth, nitroglycerin becomes much less shock sensitive and can be handled safely. And he was the discoverer of dynamite. And now Alfred Nobel envisioned dynamite as being useful in digging tunnels and so also construction projects. Unfortunately, that vision didn't really come. It did come true, but the dynamite became much more used in warfare, and that in part prompted him to make up his now very famous endowment, which awards Nobel Prizes in several disciplines each year. Finally, the last class of inorganic esters we will discuss are the phosphorate esters. So they are esters formerly of phosphoric acid. And phosphoric acid can exchange up to 3 of its OH groups for alkoxy groups to give us finally phosphate esters. And these phosphate esters are very interesting in biology. They serve as a building unit of our DNA. So our DNA nucleic bases are strung around these long chains of phosphate esters. And also phosphate esters serve as energy sources in our bodies. So the molecule known as adenosine triphosphate, ATP, is our body's energy currency. Its hydrolysis releases all the energy that we use in our metabolic processes.